Now, I want to explain this entity linking task, but using a simple hierarchical multitask approach. This article in 2020. So recognizing and linking entities is a crucial first step to many tasks in biomedical text analysis, such as relation extraction and target identification. Traditionally, biomedical entity linking methods rely heavily on heuristic rules and predefined, often domain-specific features. The features try to capture the properties of entities and complex multi-step architectures to detect and subsequently link entity mentions. So they propose a significant simplification to biomedical entity linking that does not rely on any heuristic methods. The system performs all the steps of entity linking jointly in either a single or two stages. They explore the use of hierarchical multitask learning using mention recognition and entity typing tasks as auxiliary tasks. So we have two auxiliary tasks, mention recognition and entity typing. And then they show that hierarchical multitask models consistently outperform single task models when trained tasks are homogeneous. So our main task, which we refer to entity linking, aims at classifying each token or mention to an appropriate entity concept unique identifier. For example, if you are working with UMLS in biomedical text, we related mention to its entity in this or concept in this database. So they make use of two other tasks, entity typing and mention recognition. These are their auxiliary tasks. And you see, the reason that they call it simple is because for each token, they find the entity link or it is others, something that hasn't found, or it founds some concept in the database. For example, here it has found this concept that corresponds to this mention, or this concept that corresponds to this mention. So as you see, this is the architecture of the multitask model. And so they outline three models: single task model and multitask model, and hierarchical multitask. All models take a sentence with the surrounding context as their input and output a prediction for a token. And for tokenization, embedding layer and encoder, they use Cybert. So they have the task of mention detection, entity typing, these are auxiliary tasks, and finally we have the task of entity linking. But you can also use it this way, that you say that you have a sentence, you give it to that Cybert to have a better representation, word piece representation, and then you give it to the transformer encoder. Now you give it to the encoder by LSTM to have the task of mention detection, or another by LSTM to take the task of entity typing. And our main task is entity linking. So you see how hierarchical it is, and the idea is very simple. And the single task model only adds a feed-forward neural network at the top of the encoder transformer, which acts as a decoder. And for training, they use this loss, and here Y is just the target label for token I in a sequence J for class K, and this H is your prediction for token Tij, this token, and you want to see if it is for class K or not. And then you learn these parameter theta to find the entity linking. So they found that using context namely the sentence after and before a sentence of interest, very beneficial for the encoder. After the encoder, the context sentences are discarded from further steps. And you see in the training details that we have, they use med mentions for their dataset and also bio-CDR. But the number of mentions of med mentions is quite high, 300,000 mentions. And they compare it with the SPICY model, with BioLSTM CRF, which is a very simple approach that we use for example, part of speech tagging. And you see there is a quite slight improvement to 82%. Instead of BioLSTM CRF, they use this hierarchical approach. 3% improvement and 1% improvement for F1 accuracy. This is precision, recall, accuracy, and F1 score. And for anti-typing, which is, as I said, an auxiliary task, they have some improvement as well. For example, the improvement, we have 3% improvement for F1 accuracy in comparison to BioLSTM CRF. And for entity linking, which is the main task, in comparison to other tasks, these are the auxiliary tasks. So finally, the entity linking, we see quite some improvement from, if you compare the BioLSTM CRF, the F1 score of that, then it's around 12 improvements.